This is an update on how to run the sim and how to link your program to it. The folder you're going to have is this one here. It says RBS Aero 12.1 GNC distribution. This one is an updated one to the one that you saw in the last video. But if you open that up, you can see that there are a variety of different folders. I'll just briefly walk through. This first folder right here has some different information in it. One of the most useful things to you in here will be the instruction manual to the sim. It's a little bit out of date, but most of the commands are still correct. You know, for example, the V key toggles your view around. WASD keys, just like a video game, move you around the vehicle. The scroll key zooms in and out, and spacebar is the launch or pause toggle, and a variety of other things in here. So it's pretty short manual and relatively easy to use the sim if you've read this. So I recommend you scan through that first. The next folder that will be important to you is the interface folder. Inside here, there's a couple of things that you'll use. One is this interface.param file. Inside this file, there are different things like the password to use the sim. That's a current one. Screen resolution if you want to try to make it larger or smaller. Which SAS or stability augmentation mode would you like to be in for default? You notice I have a GNC one set as default. That's the one that you can modify. And then the other things, this CITL is so that you could use the sim with ArduPilot. And then this is the RC pilot location, the formation location, and then also some view information that kind of helps your RC pilot view defaults if you don't like them, if you'd like to change them around. The other thing that you'll need to do inside this folder, and you should only need to do this one time, is run the joystick calibrator. So the RBS joystick executable, what it will do is it'll replace this joystick map file. So I'm going to go ahead and run that now, and you can see what it'll do. You don't have to run this every time you run the sim. You should only have to run it once on your computer, and then it'll save the joystick map for your joystick. So if you click and run this, different computers will tell you have different joysticks, you know, depending on the USB devices that you have connected to your computer and how many different kinds of them are like joysticks. It might find more than one. But on my computer right now, it found one joystick with 5 axes, 5 buttons detected, and all I got to do is hit C to calibrate the joystick. And so you just follow the instructions. Release all controls, hold full aft throttle, hit enter, release all controls, full forward throttle, left rudder, right rudder, left aileron, right aileron, full aft elevator, forward elevator. I have one button on my device that I want to use for the pause toggle, so I'm going to use that. So I'll hit yes, yes, press and hold the button you want to use for pause launch. I'm holding it right now, hit enter, and then I'll just hit no for the rest of these. Okay, it's all done, and you see this joystick map file has been modified. Okay, you won't need this folder. Output data, it's explained in the manual, but here you can actually, in this file right here, every time you close the simulator window, it'll save all your flight data. In fact, if I open up one of these, you can see Time, X location, Z location, phi, theta, psi, U, V, W, P, Q, and R, and so forth. A lot of information. And in fact, you can tell the simulator what information to save if you go back into the interface folder and you go to output variable map. And anything that has a double slash next to it, if it's commented out, it won't print that. So you see it's printing T, X, not Y, Z, not MSL, phi, theta, so forth. So you can uncomment these if you want these to print out, or you can comment all of them so that you don't have such a big file. None of this is important in here, with the exception now of the vehicles. Now I've got the F-16 set up here. And you notice there's a variety of different parameter files in here, or I call them attribute files. Here's the vehicle rigid body folder, or file, I'm sorry. And if I open this up, there's a variety of information in here. Now I've got this, I have this one set up right now so that it'll actually start in flight at 6,000 feet, and it's like going 293 feet per second. And this was so that you could play around with one of the observers I have in there. So actually what I'm going to do, I'll show you how to, if you wanted to create a new airplane here, I'm going to copy this one. And I'm just going to call that the observer plane. And then I can go back into here in the interface. This is the airplanes file. Okay. And so now that'll show up later. Okay, so let me modify this F-16 file. This is one, I'll make it so that this one starts at the end of the runway. Okay, and so it's the weight of the airplane, how much fuel is in it, the inertia matrix. These are all for, this is data for a real F-16. So that's the rigid body information. This static object selects. These are just the things that are going to be visually seen in the sim while you look around. There's the gains file. You notice all these gains down here that I'm highlighting. These are gains, and in particular, like the 4.1 new parameters here, but also these. I might as well, even for you, delete these because you won't need the 4.0 ones. If you want to run my interpretation of the ArduPilot stability augmentation system, you can actually run this and change these different parameters for your airplane. But there's also, in the GNC SAS that I've set up for you that I'll show you in a minute, there are also some things that you can set up. I've already got information in here for an observer, but the files that, or the parameters you'll really need for the project are the K matrix. These are the feedback matrices, or the feedback gain vector. So the way this is set up, this is K0, K1, K2, K3. So for example, if you're using state variable feedback on Q, this one right now, you see Q has a feedback gain of 1. So you can change this so that you can actually run different gains. Now, I'll show you that when we fly the airplane. This is propulsion information for this airplane. And then this is the F-16 analysis, aerodynamic analysis, all the stability derivatives and all the other information about it. You don't need to modify any of that. Okay, and then there's some other airplanes in here, but the F-16 is the one that you can feel free to play with any one you want. But you see the Navion is even in here, you know, the one from Nelson's book. But the F-16 is the one you'll be using in the project. And so these are all the different object files. In other words, these are all, in my version of the code, these all have their source files that these have all been already, they've all been compiled for you already into OBJ files, so they just need to be linked. And the only thing that really needs to be compiled is your SAS, your SAS source code. And actually, let me close this down so I can show you how to start this. So you'll have Visual Studio already loaded on your computer. You come down here, you see it's the SLN, the solution file. You double click that and Visual Studio will open. And you'll see how everything is set up here. And the only file you'll be able to or want to edit is the SAS code. That's the source code. You also have access to the SAS header file if you want to add a variable or something like that. But here's the SAS executable code. Or I'm sorry, not the executable. This is the source file. And so there's a lot in here, but there's a lot you don't need. The constructor, deconstructor, these are loading in all the different parameters. This is where all of that data from the gains file is read in. You see the K matrix and so forth. So all this information here, all these different ArduPilot parameters, you have access to all these. Those are all read in from the gains file. That's what all this is. So you don't need to mess around with any of those. You can, but you don't have to. And then some parameters, like if you want to use integrators, they're initialized and so forth. All these things in here, you don't need that. Here's the part of the code that you'll actually be useful. And I've got a summary here. Alpha is available, beta is available, V, P, Q, and R, phi, theta, psi, accelerations, and time step. The output from this function is going to be elevator angle, aileron angle, and rudder angle. This SAS is set up a little bit different than the one that you saw in the last video. So this is probably the biggest difference. That's why I'm doing this video. It's set up a little bit different. It gives you more options. But now out of this one function here, the control deflections. So the pitch command, the roll command, the yaw command, and so forth. And what gets calculated in here, depending on the mode that you're in, are the different control surface angles. So if your SAS mode is in manual, it does all this. If your SAS mode is gyro mode, it does this. If the SAS mode is GNC, which is the one you'll be playing around with, this is really the only section you need to play with. Right here. If SAS mode is fly-by-wire A 4.1, this is fly-by-wire A mode with ArduPilot. Like I said, you're free to mess around with that if you want. But it says, let's go back to the GNC section here. So this is the pitch section. Now I have a pitch axis observer in here you can play with, but depending on what the final deliverables are for the project, you may or may not play with this. So here's the end of the observer section. So really what you'd need to know is pitch control SAS. I already have one really simple setup for you right now. You'll notice I have, here is what pitch control would look like for the elevator using measured states where it's really output feedback, and the only thing you're measuring is alpha. So you'll notice you have gain K1 times the measured alpha times 57.3 to convert it to degrees, plus this is your elevator input from your joystick, and then this is trim if you have any trim set up in the input file, and that's it. That's about all you'd need to do. And here I have another example here if you wanted to use feedback of alpha and Q and theta. So this is the section you can play around with. Here would be control for the elevator using the observed states. You have that commented out. You won't need to mess around with this. These are just constraining, so you're not putting in more elevator than the airplane can give you. It's limited, and that's it. In here, so the state variable feedback section ends here. I've got a section in here if you want to play around and actually use PID, use that method of putting gains in there. But for feedback of state variable feedback or output feedback, literally this is the only section you're going to need to mess with here. That's for pitch. Roll, it's the same thing. The only thing I have in for roll right now is literally roll doesn't even use feedback right now. It's just, you're just putting in what the pilot is commanding. But here's an example of PID control. Here proportional, feed forward, integral, derivative. You can play around with that. If you want to know what's done for yaw control, that's all down here. But yaw control right now is set up the same. Manual is the same as GNC. In other words, it's whatever the pilot puts in, that's the yaw control you get out. Okay, so let's go ahead and run the sim. Just like I showed you before, when you make a modification to the SAS, let's say we were gonna make a modification here. You'd change this, and I don't know. Let's say you wanted to add pitch rate to this, to the feedback. You might say plus K two times Q. Okay. And then let me jump out here real quick and go to the vehicle, F16, gains. Let's see, K matrix. Let me make. Let's make the. You just play with this by hand. I'm not going to make you calculate this in MathCAD or anything like that. This is just instructional. I want you to get a feel for how you'd actually do this. Let's put in a gain of 0.5 on, this is alpha or W, could be used for either one. And what the heck, we'll just do 0.5 on each. Save that. Now to change things in this file, you don't need to recompile. But anytime you change anything within the SAS, you do need to compile. You go up here and hit the compile, that green arrow. Now here's on my computer it does this. I'm not sure if this is going to be a problem with you, but sometimes what you'll notice is it'll fail to compile. You see down here it says one failed. what you might need to do is go back up here to build, hit clean solution, then recompile it. Okay, and there it runs. So now I'm going to select airplane 4, which is the F-16. Okay, and there's the airplane at the end of the runway. I'm in pilot view right now. I could fly it like this. Let me go ahead and hit the space bar, or I can hit this button on my joystick, and the airplane's ready to go now. The simulator's running. It's not paused anymore. If I hit the V button, I can change views. You know, this is, you know, that's behind the airplane. But this view is like the chase view, and with the WASD button, I can move around the airplane. So that's good enough. So I'll go ahead and hit the space bar. And you see I can take the airplane off, and I can fly it around. Hit the space bar. I can pause again. Okay. So now what I could do is, if, for example, you want to change something, you say, oh, I want to go back in here and I want to change the gain. So I could, let's say I want to use more alpha feedback. I could save that, go back here, hit R. R will restart the sim, okay? And it will have read in that new gain file. And I can take off and fly here. And you'll see at the top of the screen, there's actually information about the airplane, different flight parameters and so forth. Okay, and as we're flying around, you know, you can change your view and so forth. So, like I said, play around with it. Okay, once you hit the X button to close out the window, now actually all the flight information that you had from that last flight will actually be in the output file that I showed you before. I'll show you that. Output data. You see this file was just created. There's all the information here from that last flight. So that could be useful to you. Let me go back in here, and I'll change it back to what I had before. Just alpha feedback. And you notice, see, once again, this is kind of a new sort of undocumented feature of Visual Studio. I don't know why it's doing this. You see how it fails. I need to clean the solution every time before I run it. In other words, anytime I change anything in this SAS. Oop, it didn't work that time. Clean the solution. Not sure what that problem is. I'll debug that offline here. But I noticed there's an update, so maybe that'll solve it. That's a relatively new thing that just started happening, I noticed. But I just wanted to show you how to go ahead and run the sim. And yep, let's see, I've covered all of that information. So I think you have now all the information necessary to go ahead and use the sim for your project. of course, you'll have some other specific questions, and you can always reach out to me, and I can help you with that. But overall, you have all the information necessary to go ahead and get started and run the sim and make your own stability augmentation system. Okay, so good luck with that, and have fun with it.